Okay, this video we're going to talk about finding the roots and why do we factor is kind of the main topic here. And something we've been working on in class is we've been studying this type of graph. This is our x-axis right here, and this is our y-axis. And this graph is called a parabola. And parabolas are these nice, like smooth U-shaped curves. And we happen to know that all parabolas have some sort of an equation that involve an x squared in it. And so the typical standard equation says y equals ax squared plus bx plus c. And the a, the b, and the c are all numbers. So I could tell you this is 5x squared plus 10x plus 4. Or I could tell you that it's 3x squared plus 7x plus 12. Or I can make up any numbers I want. But when I graph the equation, I get one of these U-shaped curves. And one of the important things about these parabolas is they usually cross the x-axis somewhere. Often, because of the shape, they'll cross in two spots. And this spot where it crosses, it's where it hits the x-axis, so we call it an x-intercept. It intercepts the x-axis. And a lot of math teachers and textbooks, that's what they're going to refer to it as an x-intercept. So we've got two x-intercepts here. But there's other names. In math, for some reason, we name everything with 3 different names. So besides calling it an x-intercept, some people refer to these points as roots. R-O-O-T. Root. So each of these are the roots of the parabola. And to figure out where the roots are, like, I don't know, maybe on the graph this is at 1, 2, 3, and 1, -1, -2. To figure out those points, -2 and 3, there's a lot of math involved. There's a lot of different ways to solve too. And one of the most powerful ways to figure it out is to use factoring. So we're going to talk about how do you find roots today. How do you find these points on a parabola? And it starts with this, actually. We're going to go down below here. It starts with something called the zero product property. And the zero product property is a really important algebraic property. It basically uses common sense. It's all about the number 0. So we know that when you multiply by 0, let's say you had 3 times 0, we know the answer is 0. If I said I had 257 times 0, you'd still say the answer is 0. If I told you I had 1/5 times 0, you'd still say the answer is 0. Doesn't matter what you're timesing by 0, you always get 0. Even if I changed it up and said, okay, now I have 4x squared times 0, you'd still say your answer is 0. So zero product property has to do with this. Anytime you're multiplying by 0, you get 0 as an answer. Even if I made it more complex, I can throw a lot of algebra in there. What if I had like a parenthesis with x plus 7 times 0? You'd still say the answer is 0. So it doesn't really matter what I make up here. I could do this forever, but I'm always going to get 0 as my answer. So here's kind of what the zero product property says. If you know you have two things, I'm going to use parentheses, two things that are multiplied, and the answer is 0. So in this first parenthesis, I have A, and this is B. But A and B can be anything, any numbers I choose. Doesn't matter. You know that one of these, well, if it's multiplying and it gets you 0, one of these has to be 0, doesn't it? So either A equals 0 or B equals 0. So basically what we say here is either A must equal 0 or B must equal 0. Or maybe they're both 0. Who knows? One of them's got to be 0. So that's where the factoring is going to come into play. We're going to talk about what happens when we have two parentheses equal to 0. So let's look at a problem here, and we'll come back to this zero product property and this parabola. And let's use this as our example. Let's say we had x squared plus 3x minus 10 and I'm going to call this a y equals, and I was asking you about the graph. What's this thing look like on a graph? You would tell me, oh, well, it's definitely a parabola. It's one of these. Because of this x squared. That's my clue. It's one of these U-shaped graphs. Okay, well, great. Now that I know it's a U-shaped graph, I want to know where are the roots of this graph. So to figure that out, we're going to set the equation equal to 0. Where does this graph equal 0? So I'm gonna make this up. I'm gonna draw x-axis and some made-up y-axis. Remember, I'm kind of guessing on this. And basically what I'm asking is, where does this whole equation equal 0? So where does it hit this line that I'm turning red right here? Where are these points? So I would try and solve for x, but I'm going to get stuck. If I add this 10 over to this side, plus 10, I get 10 equals x squared plus 3x. And how the heck am I going to solve for x? You can't combine these together. You can't divide by anything. You're gonna get stuck right away. So this is really a terrible method because of the x squared. I don't want to do this. Instead, since it's equal to 0, it's going to be simpler for me to turn it into two parentheses because I know one of these must be 0 by the zero product property rule. So how do I get two parentheses? I factor. That's what we've been practicing. We got to use factoring. So here's what I'm going to do. I'm going to do my rectangle diamond method, which we're so good at now that it's just getting really quick for us. I'm going to put these pieces in, so x squared goes in the corner, negative 10 goes across from it, 3x goes in the bottom of my diamond, and then you multiply the corners. Negative 10 times x squared is negative 10x squared, and you find two numbers that multiply to negative 10 and add to 3. So we could do 1 times 10 or 2 times 5. I'm thinking 2 times 5. And I'll make the 2 negative. 5 minus 2 is 3. Perfect. So negative 2x and 5x go in my boxes. I'm going to factor real quick. I'm going to go around the outside edges and say x times x is x squared. X times negative 2 is negative 2x. And negative 2 times 5 is negative 10. If you got lost on this, you probably should go back and watch some of those earlier factoring videos to kind of understand them. But this should be really easy for you. So we've got two answers, two parentheses, x minus 2 and x plus 5. And that's what goes here. So I'm going to change the color. I'm going to write x minus 2 and x plus 5. And normally we'd say we're done. We factored, that's our answer. But today we're trying to find the roots. We've set this equal to 0. So according to my zero product property, one of these things must be 0. Either the x minus 2 equals 0, or the x plus 5 has got to equal 0 for this to even be true. One of them, this is, on the last page of notes, this is the A and the B from that rule. So these are really easy equations to solve. If x minus 2 equals 0, then think about flipping the 2 over to a positive 2. Adding it over to the other side, x would equal 2. If x plus 5 equals 0, think about subtracting the 5 over, making it x equals negative 5. You have two answers. You have x equals 2 and x equals negative 5. And basically what that tells me is on my graph, I know where my roots are. So remember we were drawing this parabola earlier. I'm going to draw it again. Now I know on the x-axis at 1, 2, 3, 4, 5, negative 5, there's a root. And at 1, 2, there's another root. That's what it's telling me. And I know my parabola is a U-shaped graph pointing upwards, so it probably looks, well, we don't completely know, something like this. And I don't know how low it goes, and I'd probably need to find some more points to get a really good graph. But I have an idea, and at least I know here's a root, and here is another root. And I figured that out using the factoring process. So the whole point of factoring really is a tool to help us be able to solve for complex equations like this using the zero product property rule.